Hello, hello, hello everybody. Root Beer here looking at question 22. So the second question in part C on our 2009 Pascal contest. If you haven't given it a try, I would encourage you to pause the video and try it out for yourself. So here's question 22 now. In the diagram, PQ and RS are diameters of a circle with radius 4. Okay, diameters all pass through the same center. So if the radius is 4, then we get a 4 here, a 4 here, a 4 here, and a 4 here. And if PQ and RS are perpendicular, so we can draw a bunch of little right angles in there, what is the area of the shaded region? Okay, now I can see two ways to maybe approach this question. One, figure out the whole area of the circle and then subtract off these end bits here. Or the lines and the diameters gives me another way to do it. Break it down into this triangle, and these two quarter circles. And I think that's probably the easier way to approach the question. Just thinking computationally. That's all. Sure, you could do the question where you get the whole circle and subtract off those little side bits. But it's going to be a little challenging to figure out the area of those side bits. Specifically, you'll have to get the area of a quarter circle and subtract off a triangle. And if we're going to figure out the areas of quarter circles and triangles, we might as well just compute the area directly. Okay, but I think that's probably the fastest way to do this question. So we've got two triangles, both of them right angled with base and height 4. And then we've got these quarter circle sections, and so we'll talk a little bit about area of a quarter circle. Let's draw a picture here. Diameter, these guys connect up. So here we have two right-angled triangles, although they're slanted in the picture. And they have a base of height of 4 and a height of 4, and so we can just very quickly calculate the area, 1/2 base times height. Each of these is going to be an area of 8. And so together, we've got 16. Now what's left over? I'll change colors for these quarter circles. How do you know it's a quarter of a circle? Because we've got a right angle. 360 makes up a full circle. 90 over 360 is 1/4. So there's a quarter circle, there's a quarter circle. Okay, now we can either compute them separately and then double it, like I did with the triangles, or we can realize that if I've got two quarter circles, together they make a full half circle. If you find it easier to remember the formula for a semicircle of radius 4, go with that. But if I know the fraction of the circle that I want, say a quarter circle, and I know the area of a circle, pi r squared, then the area of the quarter of that circle is, quite naturally, a quarter pi r squared. So in this particular case, what have we got? We've got 1/4 pi, and the radius is 4. So this is going to be 4 pi, and again, we're going to double this because we've got two quarter circles. So we'll get 8 pi, so our final answer should be 16 plus 8 pi. And what have we got here? 16 plus 8 pi is E right there. Okay, so E is going to be our answer. And we're going to move right along to question number 23, the midway point of these Part C questions. Thank you guys so much for watching, and I will see you in the next video for question 23.